Before we get started, I just want to emphasize that my views do not represent Microsoft, Georgia Tech, Siena, or Intel. These are expressly just my views, and they do not represent the vast body of people that work or go to school at those organizations. Hi, Ms. Crow at Milton High School. My name is Farzan, and I'm here to answer a few questions you submitted me. First question is what I do. I am a software development engineer at Microsoft, and I work on the Chakra JavaScript runtime, which is essentially a multi-stage interpreter and just-in-time compiler. Chakra is a relatively new project at Microsoft. It started in 2009 as an effort to make IE faster than competing browsers at code execution. To achieve this task, they added a JIT, which included optimizations for code inlining and background compilation, as well as much more. As a result, the interpreter is an increasingly smaller part of Chakra. It is primarily used these days to garner profiling data for the JIT and for new language syntaxes. That said, it is still used to directly execute code, but that depends on how hot that section of code is. Let me explain the new terms. First, let's talk about profiling and then hot code. Imagine that you are a sandwich shop owner and you have a certain customer named Bob who always orders the same thing. So when you see him, you don't have to ask him what he wants because you remember from last time. Profiling in computers works the same way. We save time because of assumptions we can make. So now let's talk about hotness. Hotness is determined by the profiling data. We don't want to make Bob's burgers until you are established a pattern that Bob always orders burgers. Hotness is essentially our condition to determine if we can run faster by generating machine code, i.e. assembly instructions, for a section of code that is used often. Other parts of Chakra are the garbage collector and the language features. The garbage collector is necessary because we are going to generate and execute code at runtime, so you need to allocate new executable memory space to store it somewhere. Also, JavaScript developers don't manage memory, so you don't need to create a system that does. The language features are handled by another team. Essentially, every few years, a spec committee called ECMA ratifies a new set of features that JavaScript should be able to accomplish. So we work really hard to keep IE spec compliant. The hope is to reduce the burden on web developers to have to target a specific browser while giving them more expressive ways of writing code. The next question is how my career progressed. Well, it actually all started with this AP Computer Science class. I took it my senior year of high school, and I needed to make some extra money before I started college at Tech. So I got the software job at a local company in Alpharetta called Siena. My cousin, who was already at Tech, was interning there and got me the interview. And thanks to AP Computer Science, I aced the interview. From there, I did a few paid research assistantships and TA gigs at Tech, which helped me realize my passion for computer architecture, which in turn helped me land 2 internships at Intel. The first internship, I worked on the Intel Depth Camera SDK that is now appearing in Ultrabooks and tablets under the RealSense trademark. That summer I got to do some really cool stuff with computer vision using OpenCV and graphics using OpenGL. The second internship I worked on the Intel Media SDK, which allows you to do hardware accelerated encoding of H.264 video. I worked on a few product improvements and filed a few graphics driver bugs, but my primary job was to write a plugin to record video games or stream them to YouTube and Twitch. Our demo game was Minecraft, and I got to demo this to Justin Ratner, who at the time was the Intel CTO. After that, I went on my full-time job hunt and landed at Microsoft doing cool work on Chakra. The next question is, why should someone take a computing class? I think computer science helps develop an analytical mind. And if we have more problem solvers that approach any kind of problem as, oh, this is one of many ways we can do X problem, where the end goal is to find one of many paths to a solution, could benefit other fields. That said, it is not an endorsement for everyone to become a computer scientist. This job can be very tedious. I warn you that while an introductory knowledge is great, you should only want to make a career of this if you are really passionate about it. Passion is what is going to get you through working on the annoying stuff so that you are still excited about your job when the cool projects come around. The next question is, how have I used computer science? Well, every job I have had thus far has been a software development job. I really hope it stays that way. I think I do more work as a scientist now than before because getting performance for compilers requires a lot of experimentation and tuning. Sometimes you have a hunch that something will be more performant and it will turn out completely wrong. I like the uncertainty. It makes it feel like we are still exploring to find out what the solution is. I also feel like I do more now with computer science because I do work on compilers. Compilers essentially made everything we have seen in computing possible, starting with the introduction of context-free grammars by Noam Chomsky. So context-free grammars are a formal grammar that defines how a symbol can be replaced by another set of symbols. It is essentially what maps assembly code to more expressive and abstract programming language. Hi, I'm going to end it here. This goes on for a little while, and I don't really want to talk over anyone's head. So thank you for listening, and thank you for the questions. Goodbye.